Hey guys, what's up? Welcome back to my YouTube channel, Tech Rock. In this video, we'll be covering what loci is in engineering drawing. Generally, we'll talk on the basics of loci, the types of loci. Each examples will have to list all under them, as well as the way to construct them and the way to derive them from questions. So what's loci? Loci in the context of engineering drawing refers to the path or trajectory traced by a point or line as it moves throughout space. This concept is fundamental to understanding and constructing various geometric shapes. So what this basically means is that loci is formed when a point or a line moving through space. When a point or a line is moving through space, so the path or the trajectory of that point or line is what is called the loci. So in this video, we'll be starting with the introduction to geometric concepts in loci. We'll talk about the key geometric concepts that are fundamental in engineering designs, which are 1. Cam profiles, 2. Ellipses, 3. Hyperbolas, 4. Parabolas, 5. Involutes, 6. Cycloids, 7. Epicycloids and Hypocycloids. Understanding these constructions and application of these geometric shapes will provide you with the essential tools needed to effectively communicate and visualize complex engineering designs. First, we have the cam profile. The cam profile is a curved surface that converts rotary motion into linear or oscillatory motion. It's a fundamental component in many mechanical devices, from automobile engines to clocks. The most common cam profile shapes include circular, elliptical, parabolic, and involute. Each shape produces a unique motion pattern to suit different application requirements. The importance of a cam profile is that it plays a crucial role in the design and operation of a wide range of mechanical systems, from robotics to automation to aerospace and transportation application. The next geometric shape we'd like to talk about is the ellipse. The ellipse is a closed two-dimensional shape that resembles an elongated circle. It's defined by two focal points and the distance between them, known as the major and minor axis. Ellipses are commonly found in nature, architecture, and engineering applications. The methods of constructing an ellipse are 1. Focal point method, 2. Auxiliary or concentric circle method, 3. Approximate method. All these will be covered in our videos. The next geometric shape we'd like to talk about is the hyperbola. The hyperbola is a conic section formed by the intersection of a plane and a double-napped cone. It's characterized by two branches that curve away from each other, creating a distinctive open shape, as shown by the right. It has an eccentricity that is greater than 1. Hyperbolas have different practical uses in various fields, like engineering, physics, as well as mathematics. The uses include modeling the path of projectiles, the shape of satellite orbits, and the vibration of certain mechanical systems. The methods of constructing an hyperbola include the directrix method and the circumscribing rectangle method. Both will be described in our subsequent videos. Next geometric shape is the parabola. The parabola is a particular type of conic section formed by the intersection of a plane and a right circular cone. It is symmetrical and it is U-shaped. It's a U-shaped curve that is widely used in engineering and design applications. Some of the important properties of a parabola is the ability to focus light and sound waves, making it useful in reflectors, telescopes, as well as other devices. The methods of constructing a parabola include the directrix method, the parabolic rectangle method, and the parabolic envelope method. The first and the second will be described in our subsequent videos. The next is the cycloid. The cycloid is a curve traced by a point on the circumference of a circle as it rolls along a straight line without slipping. Some of the applications of the cycloid are roulette design for gambling wheels, trochoidal wave theory in fluid dynamics, cycloid pendulum in clocks and oscillators, as well as cycloidal gears for power transmission. The next is an involute. An involute is a particular type of curve that is generated by a point on the circumference of a circle as it rolls along a straight line. Unlike a cycloid, which is formed by a point on the circumference of a rolling circle, an involute is generated by a point that is fixed on the circle. The uses of an involute include gear designs, cam profiles as stated above, architectural designs, as well as kinematic analysis. Now on to the last, which are epicycloids and hypocycloids. First, epicycloids. What is epicycloids? Epicycloids are curves generated by a point on the circumference of a circle rolling on the outside of another circle. Yes, this looks similar to the cycloid, which rolls on a straight line. But these epicycloids roll on the outside of another circle. Their applications include gear designs, roulettes, and decorative patterns. The hypocycloids. These are curves generated by a point on the circumference of a circle rolling on the inside of another circle. So cycloids roll on a straight line, epicycloids roll on the outside of another circle, hypocycloids roll on the inside of another circle. The applications include gear designs, cam profiles, and architectural elements. That's it, guys. Thanks for watching. See you in the next video.